The Indian military has identified 19 specific technologies to modernize its fighting force. To get them, the government is offering a $3 million prize to anyone in the private sector who can build these sovereign, deep-tech systems from the ground up. Major military powers are already pouring massive capital into this space. The United States has the Replicator program, aimed at deploying thousands of networked autonomous systems, backed by a planned $30 billion push into AI supercomputing by 2027. This document details India's strategic response via ADITI 2.0 and 4.0 initiatives. The program offers to fund up to 50% of development budgets, capped at 25 crore rupees, targeting these exact 19 problem statements distributed across the Army, Navy, Air Force, and Coast Guard. The most advanced weapons in the world are useless if the soldiers operating them run out of fuel, ammunition, or oxygen. In high-altitude or contested environments, the last tactical mile is the most dangerous stretch of terrain on Earth. Getting supplies across that final mile requires human beings to expose themselves to extreme physical and tactical risk. We're breaking down all 19 of these classified research challenges to see exactly how India is building its future military. If you want to track the future of global defense technology, hit subscribe to Autonomous Warfare. The ADITI roadmap suggests that the path to autonomous strikes begins with automating the supply chain, reducing the human footprint in high-risk zones. Phase 1 of the ADITI arsenal focuses on the backbone of the battlefield, securing data streams and automating decision support systems. This problem statement outlines the requirements for a military-grade 5G handset. The Army needs to reduce the physical footprint of base stations in the tactical battle area. By deploying AI as a service platforms alongside these high-gain, dual-band 5G devices, they can stretch mobile network coverage over greater distances with fewer vulnerable relay points. The hardware specs for these handsets require heavy encryption capabilities, demanding a dedicated slot for a hardware security chip and a detachable S-band satellite sleeve to ensure connectivity never drops, even in dead zones. Physical logistics receive the same automated treatment. The document calls for the development of portable, battery-operated towing aggregates to move heavy equipment silently, paired with advanced rubberized fuel tanks to securely store and transport aviation turbine fuel across difficult terrain. Securing these data streams and automating fuel storage establishes the infrastructure needed to support autonomous units in the field. Once the supply lines are secured, Phase 2 shifts focus to protecting those assets from the unique threats of modern warfare, specifically drones and electronic interference. Armored fighting vehicles like the T-90 tank pictured here are highly vulnerable to precision strikes from small, unmanned aerial vehicles. The traditional 12.7mm anti-aircraft guns are struggling to hit these nimble targets. To counter this, the Army is soliciting adaptive camouflage to hide the vehicles, and specialized fragmentation rounds designed specifically to detect and shred incoming drones. On the water, naval vessels face a different threat. Standard GNSS signals can be easily degraded or spoofed by cheap jammers. To solve this, the Navy is requesting a passive quantum positioning system. Once aligned, this quantum node must maintain precise position, navigation, and timing accuracy for over 10 days completely in the dark, without any external satellite input. Looking at the Air Force requirements, this challenge document details a counter-swarm drone system. The objective is to launch an autonomous swarm of interceptors to neutralize an incoming enemy swarm using a mix of hard kinetic kills, optical disruptors, and electromagnetic pulses. The defensive shield is rounded out with requests for indigenous infrared detectors, space weather packages for orbital awareness, personal oxygen delivery systems, and universal anti-G suit test rigs for fighter pilots. Survival on a modern battlefield relies heavily on algorithmic interception and environmental awareness. With the foundation built and the defensive shield in place, Phase 3 of the ADITI documents transitions into offensive strike systems. Here, the Navy is asking for collaborative combat air vehicles. These are semi-autonomous drones designed to operate as wingmen alongside manned fighters in highly contested environments. They are paired with requests for the design and development of high-power laser sources exceeding 10 kilowatts for directed energy engagements. For ground forces, the Army wants to upgrade existing artillery. This is the Pinaka multi-barrel rocket launcher. Rather than firing standard rockets, the challenge asks for a multi-barrel loiter munition system capable of launching 10 or more kamikaze drones in a single salvo directly from this platform, extending their precise strike range up to 500 kilometers. The final elements of the offensive and transport arsenal include 76mm dart ammunition with radio frequency guidance, road-mobile tethered aerostats for persistent surveillance, autonomous orbital docking technology for spacecraft, and specialized hovercrafts for military operations. Combined, these specific technologies form a dense kill web. They bridge the gap between identifying a threat and eliminating it with minimal human intervention. The ADITI program is explicitly designed to move past basic component prototypes. The ultimate goal of the 4.0 elite tier is to deploy complex, deep-tech systems, scaling up to humanoid robots and autonomous load carriers. The benchmark for these systems isn't flawless, error-free perfection in a laboratory. The benchmark is reliable performance under the extreme stress, dirt, and chaos of an actual battlefield. A machine can process data faster, operate without sleep, and calculate targeting telemetry in milliseconds. But as these machines take their place on the front lines, their success depends on whether the soldiers fighting beside them believe the system will work when it matters. Thanks for watching. Which of these 19 technologies do you think will be deployed on the battlefield first? Let us know in the comments below. Be sure to like, share, and subscribe, and check out the links in the description for more on the future of autonomous warfare.